Hi and welcome to our next video. This is about three-part inequalities, applications with three-part inequalities. We're going to look at this word problem. The median income, L, of a family in thousands of dollars from 2000 to 2005 can be modeled by the function L of x equals 1400 times x minus 2000 plus 51,000, where x is the year. Determine the years when the median income ranged from $52,400 and $56,600. So what is this saying? So we are looking at a range, and when we look at a range, we think kind of in between. We want the median income, to be in between those two values. So we're going to look at this three different ways. We're going to solve it symbolically, numerically, and graphically. So symbolically, meaning algebraically, I want the income to be between 52,400 and 56,600. So what's the income? Well, the income is modeled by 1,400 times x minus 2,000. Didn't leave myself enough space, plus 51,000. So this is a way to think, instead of solving one where it's greater than or equal to 52,400 and a separate inequality of less than or 56,600, we know it has to be between these, so we can set up this three-part inequality. That's what this is useful for. So how do we do this? Well, we're going to solve this the same way we would algebraically any other way. Personally, I would subtract 51,000 off of all three sides first. And it's going to give me a little bit more space. I could distribute and then combine like terms, but I'm going to make my number smaller by just subtracting 51,000 from both sides, all three sides. So that leaves 1,400. When I take 52,400 minus 51,000, I get 1,400. This is 1,400 times x minus 2,000. And when I take 51,000 off of 56, I get 5,600. Okay. Now what could I do? Well, I can distribute, or I could divide all sides by 1,400. So that's going to be 1 less than or equal to, what happens here? Well, the 1,400 divided by 1,400 just makes 1, so I'm left with x minus 2,000 is less than, let's see, 5,600 divided by 1,400 is 4. Now we just need to add 2,000 to all three sides, so I get 2,001 to 2,004. So what is this implying? This is saying that x is the year, ranges from between 2001 to 2004. That's the solution. So let's kind of think about interpreting. What is this saying? When x is between 2001 and 2004, the median income is between 52,400 and 56,600. That's what what the solution is meaning. We're going to write that in a sentence in a little bit, but let's first also see how we could solve this numerically and graphically. So numerically means with a table. Graphically means we're going to graph it on a XY plane. So let's take a look at Desmos. Desmos can do both of these for us. So when you are in Desmos, let me scoot this down so you can see all of the things. When you're in desmos.com, you can make a table. So if you click on that plus sign and click table, we want to leave x as our input variable. And then on the right side of the table, we're going to put in our function. We're just going to type that in. So that was x minus 2,000. Oh, I forgot the x sub 1. So kind of an odd thing about Desmos is that if it's, we have to have this kind of subscript 1 if the input, so if the input right here is x sub 1, then that's what we need to put in our function. And you do that by, let me go back. You do that by typing x and then shift underscore, and then that's how you get that little sub 1. Parentheses plus 51,000. Okay, so we want to start. It says in the problem, in our original problem, that this is good from 2000 to 2005. So our table shouldn't start at 0 or shouldn't start at 1. It should start at 2000. Okay, so in the year 2000, the median income was 51,000. If I go to hit enter, I get to the next line. I can hit 2001, and then it's noticing I'm stepping by 1. So all I'm doing is hitting return, and I'm going to stop at 2005 because my model is only good from 2000 to 2005. That's the domain of that function. So numerically, I want to know what are the years, determine the years when the median income ranged from 52,400 to 56,600. So I see 52,400 is 2001, up to 56,600, 2004, which is the exact same thing that we were told when we solved it symbolically. That was the same solution. So that is how we solve that numerically. Now we can use Desmos to graph it, and so we're going to say L of x is equal to 1400 times x minus 2000 plus 51,000. And I graphed, I hit it. Where's the graph? Well, remember our domain is from 2000 to 2005. And what are the output numbers going to be like? Look at this table. They're in the 50,000 range. So we need to go to our graph settings over in the top right. Looks like a wrench. And we're going to have to change our x and y axis. So our x-axis is going to, that's our input, it's going to range from 2000 to 2005. Still don't see anything. That's because our y-axis is not in the right zone. So we're going to start at 50,000 up to 60,000. Okay. 50,000 to 60,000. Make sure I have all the right number of zeros here. Huh. Sometimes it does that kind of business. Well, there's my graph. I'm going to go back and I'm going to change that x-axis again to 2000 to 2006 or 2005. That was, there we go. Now we can see that. We're going to step by ones. If you noticed before, when I didn't have that, it was stepping by 0.5s, which makes it a little confusing since we're talking about years. So there we have the green dots represent the table. And what we want to know is when is the income range from 52,400 to 56,000. So one way to do that is to say, okay, I want to know when is y 52,400. So I'm just putting that in. It makes that black line. I want to see the other line of 56,600. So here are my bounds. I want to know, I'm interested in when this purple function is between that black and that red line. And so we see at 2001 is the lowest point between those ranges, that range, and here at 2004 is the highest point in that range. And again, that jives, that works with what we saw in the table as well as symbolically. Okay, so here's one for you to try and bring to class. Michelle wanted to buy some mulch for their spring garden. Each cubic yard of mulch cost $27 and delivery for any size load was $40. So this could be modeled by the cost of X yards of mulch is 40 plus 27X, where X is the number of yards of mulch. If they wanted to spend between $200 and $300, set up and solve a compound inequality and solve for the number of cubic yards that they could buy. So bring to class that compound inequality and the solution.